Dr. Willie H is an astrophysicist, geoscientist, and leading authority on the relationship between solar phenomena and global climate. Dr. Soon will highlight scientific evidence demonstrating that atmospheric CO2 plays a secondary role in Earth's weather and climate, emphasizing its critical importance for the biosphere and the limitations of current state-of-the-art climate models, which are inadequate for guiding environmental and energy policies. Dr. Soon will also present evidence linking natural climate variability and change to the sun's energy orbit. We want to welcome not only Dr. Soon, but Dr. Soon's son, Ben, who's sitting right there in the back. There he is right there. Without further ado, let me present to you Dr. Willie Soon.
Given that the average size of the audience for my talk is usually 5, and that includes Ben. So it's truly very happy to be here. Well, I'm a scientist. I care nothing about, I really don't care much except for food and science, you know. And I've been working on this topic for 35 years, since my postdoctoral level at Harvard and Smithsonian Center for Astrophysics. So this is actually a bit of a passion of mine. Hopefully that there will be people who disagree with me, but please hear me out. And then, of course, if you have questions, you can always find me at the address, my email address, willie@ceres-science.com. CERES stands for Center for Environmental Research and Earth Sciences, okay? So please contact me there for any question, or if I speak too much or with my Tennessee accent that I learned from Al Gore, so you all be careful with that. Let me start. We want to learn about CO2. By the way, I do want to ask a question, a survey. How many of you believe that this CO2, they call it the satanic gas, is capable of driving global climate change? How many of you think that? A few. Okay, that's good. But I hope to convince you that with the evidence that's given here, it's very remotely implausible nearly, okay? And hopefully the evidence will make some sense. And then I'll explain, of course, further. I want to start with this very important quote. It's a friend of mine, Professor Richard Lindzen, Professor Emeritus at MIT. He said that what historians will definitely wonder about in future centuries is how deeply flawed logic, obscured by shrewd and unrelenting propaganda, actually enable a coalition of powerful special interests to convince nearly everyone in the world that the CO2 from human industry was a dangerous planet-destroying toxin. It will be remembered as the greatest mass delusion in the history of the world, that CO2, the life of plants, was considered for a time to be a deadly poison. Professor Lindzen is no lightweight. He's a very serious scientist. In fact, he's among the youngest scientists ever to be elected to the member National Academy of Science at about 36 years old. He got his PhD at 24, roughly the same like me, but it doesn't mean that I'm that smart. But let me start with the history of this climate change scare. Basically, the idea is that CO2 is a greenhouse gas, that you have more of this CO2, doesn't matter what the source is, right? Because we know volcano is capable of putting a lot of CO2 too, but we human, indeed, from changing from biomass burning to killing whales, and then we come down to find this thing called fossil fuel, right? This hydrocarbon that is very compact, very efficient, that when we burn it, it's actually able to drive very useful energy, which is mean coal, natural gas, and what you call coal, natural gas, and oil, petroleum, right? So people think that in 1988, there was already very amazing statement came out from a guy named James Hansen. He's a former director of the NASA Goddard Institute for Space Study in New York. He actually, in this New York Times, 1988, remember, that's long ago, he was claiming that he's 99% confident. In science, when you use a word like this, that's really very appalling, because it really sounded like it's going to be nothing but the truth. Unfortunately, this is a false statement by itself. And I'll show you why. So let me start with talking about this hailing the CO2, which you see some people call it satanic gas. Remember, CO2, where does it come from? This is CO2. That's 4% of it. Outside that is actually 100 times smaller. Okay? So this is how they convince people that it looks like that. You have a global temperature curve. I will explain, of course, the flaw of this curve later. That you have a temperature curve from 1880 to present. It's warming up. Looks convincing. I tell you that this data is not so correct. And then you compare that with the CO2 concentration. You find a really very good correlation. So CO2, global warming. So there is a positive correlation. Very impressive. But in science, what's the golden rule? Anybody know? Correlation doesn't mean causation, okay? Because we need to understand what causes the energy of the system to change. Hint, hint, hint. It's actually Bob, B-O-B, the bright orange ball out there, right? Today it's a bit not active. But anyway, here's a real proof of good statistical correlation. It's actually US spending on science and space technology versus suicide by hanging, strangulation, and suffocation. Because two parallel lines is perfectly correlated, okay? If you know a bit of statistics. The next one is that if you want to believe CO2 causes global warming, and then you want to win many Nobel Prizes, not only one, you want a lot. So all you need to do, I encourage you to eat a lot of chocolate tonight. That's basically what it is. There is a correlation here. But does chocolate consumption really can give you more Nobel Prizes? I kind of don't think so, right? It's a bit hard to find the actual reason for how it does. Maybe eat chocolate make you smart, who knows? Higher IQ, right? Anyway, here's the proof. I would say 100%. If I were to look at this data, that this is a temperature data, but you plotted monthly, not year by year, monthly, from about 1900 or 1895 until now. And then you see it's going up and down, up and down and down. The range of the temperature is 45 degrees Fahrenheit in the seasonal range. And then the red curve is actually the annual average. You see, when you plot on this scale, and then you plot the CO2 concentration rising for about 120 years or so, right? I mean, kind of hard to see that CO2 is causing the thing to change. That's why the perspective is very important. When you look at data, you have to be very careful what you're looking at. Always ask questions. That's what I would encourage everybody to do. Here's the bottom line. Over the US, you can see the temperature seasonal range is over 45 degrees Fahrenheit or 25 degrees Celsius, right? And then if you think about the energy input of this thing, where is it? It's actually solar radiation. It's about 210 watt per meter square. So that actually gives you a very nice number, which means that even if we worry about CO2, the bottom line is that if you double the amount of CO2, if you count the thing, you would only produce at most is 1 degree Fahrenheit. That's 10 degrees or 3 degrees, so hot. It's really hot, sorry. But it tells you that 1 degree over 150 years actually is minuscule. It is not a threat. It is not something that can kill humanity. That's what I'm trying to tell you. And then you got to look at another angle, which is the biosphere perspective, okay? So let's talk about climate. Continue to talk about climate. So here's a picture showing you the energy input from the sun and then from the actually changes in the carbon dioxide. For 150 years, this is how much we added. From the dotted line to the bottom, it's tiny amount. And remember, look, it doesn't follow the seasonal cycle. It doesn't quite make sense in terms of seasonal perspective. Here's another perspective. If you measure using satellite, looking down on Earth, you measure, by the way, CO2 interact in a long wave, the infrared radiation. Sun involved in the short wave radiation, right? I see some younger kids, I hope they'll be interested in science in here. But if you try to look for CO2 impact that has been rising so far, you will see it's tiny amount compared to the total energy changes in the top of the atmosphere and then at the atmosphere itself and then near the surface. It's fluctuating so big, up and down, and then this is what we are looking for. Needle in a haystack. It's a serious scientific problem. This is why if you look at the New York State temperature curve, same thing again, plotting monthly, you will see it's 50 degrees. New York, of course, is a smaller region, so you average, a seasonal average is much bigger than United States as a whole, right? It is really hard to find CO2 fingerprint in here. But they keep pointing, they try to lure you to look at the angle that is only coming from these annual changes where we can explain actually a lot of the problem in the temperature record. So you can imagine in city like New York, Albany, and Buffalo, a 70-degree range. And then you want to look for the doubling of CO2? Doubling. I'm not even talking about current level. You double it. And that's how it is. You're just not going to be able to see this, okay? I hope you see that the road is not so straightforward as they would say, okay? So somebody should be fired for painting that road sign, right? Anyway, I want to handle another aspect because most of the alarmism about CO2 causing carbon dioxide come from so-called computer climate models, okay? They try to take the Earth and then they try to use computer, put everything into it, put every knowledge we have, every scientific principle and rules and everything we have, and then try to produce something. But I think we're in an age of AI that is called artificial ignorance. It's a very dangerous thing because don't put the blind faith. Let me start with this. It's actually a statement from somebody who won actually a Nobel Prize in chemistry. It's impressive. His work is on buckyball, C16. Carbon, 60 of them look like a soccer ball. Beautiful work, the discovery in 1996. But he also caught on to this kind of passion about something discontent about how we use energy in the whole system. But I think that's a separate issue we should address in a civil manner, discuss it properly, right? But he also said that the sobering conclusion about future warming are projections based on elaborate models of the Earth. He said we're not talking about one scientist model, but a number of programs give similar result. He's essentially telling you that you can average floor model and make it better. That's what I'm trying to tell you. So let me illustrate it with a cartoon. What do you think the average passenger jet would look like if you have about 16 of this passenger jet? Would you go on this? The question is, would you or Al Gore go on this airplane? I don't think so. This is what you mean when you average things that is flawed, it doesn't make it better. I'm very sorry to Professor, he's at Rice University. I'm very sorry to him. In fact, I used that curve at Rice University, by the way. So I'm invited to Rice University twice. So the bottom line about computer climate model is that you give me a faster computer, I'll give you the wrong result sooner. This is a very serious statement. I'm very confident in doing this. As I say, it's from 35 years of hard work. I have produced computer climate model myself. I've done many generations, many ways of doing this. Another simple test. How you ask yourself, can the 24 climate model listed here produce a seasonal or the annual cycle? Just take that from 1954 to 2000. You will see it's not well at all. Look, every single model doesn't get the seasonal cycle correctly. Yeah, this power run off. We need to change battery. Okay, I'll continue talking. The next one is actually asking about how climate models produce precipitation, rainfall. Okay? At the top panel here, you can see that's basically the observation, what we can observe from rain gauges, right? Over about 100 years or so. You can see, the bottom is the observation.
Use this.
Yeah, the bottom is the observation. Okay, please.
We're set up. Yep.
Okay, we're set up.
Yep.
All right, we're back to business. Thank you.
Yep.
Right. Thank you. All right. Sorry, the bottom is the observation, the top is climate model. You can see that in terms of rainfall, it's a much, much difficult problem. That in the Sahara region, notice that the purple is actually mean that it's dry. When you observe it's dry, but actually they're predicting a wet Sahara. And then because I gave this slide to one of my friends who is a senator for Oregon State, so I focused on Oregon for him. The model actually predicted dry Oregon, but Oregon is pretty much wet according to the data. I mean, I want to make another important point here. Even when you see their agreement, does that mean the climate model is good all of a sudden for that region alone? I don't want to use the word hell no, but it's actually no. Absolutely not. Be careful. Another problem. You think that data may be all? Remember, I started this work since 1991. I've been watching year after year after year. Now it's 3.5 decades. It's the same thing. It's actually because of the nature of funding, no one worked to improve this thing. In fact, I'm the one who worked to improve this model, how to do it. And this is the latest 2025 paper that just came out, scientific paper. It shows you that the model predicts too much cloud. Cloud, as you can see, is the main governing of energy input-output of the Earth. It's very important. Whereas the top, you see satellite observation show you something, so there's a bit, the red mean a lot of cloud, and then the blue mean very little cloud. But you can see that most of the climate model over-predict. There's a lot of red. This is two different models, in actually the best of the best. In fact, the second model there is the one that the best prediction for Atlantic hurricane come from that model, okay, the UK group. And here's from the bar chart, it's much easier to look. The observation is the black, and then the data, the two of the model actually are disagreeing. And the difference is more than 10 to 20% of cloud cover. You know, if you double the carbon dioxide in the system, right, how much you require to change in a cloud to get a doubling is 1%, 2%, that's it. And this is 10% difference. We're talking about very serious problem. Snow cover is so obvious that you can see all the model over-predict what is observed. It's ridiculous, actually. It's a huge amount. It's embarrassing. I wouldn't call this science in some sense. It's kind of a, what you call voodoo science. Now let's listen to Al Gore about climate prediction. This is actually a very important lecture. He gave this in 2007 in Oslo in the acceptance of his Nobel Peace Prize. And you will see, during that place, he went boldly where no man dared to go before. So he predict again that the Arctic sea ice will disappear in 7 years. So 2007, at least I know how to add 7 to that. That will be 2014, correct? Okay, let's hear him. Where's the volume, guys? Ben?
7 years from now. In the last few months, it has been harder and harder to misinterpret the signs that our world
Start
is
it back
spinning
again.
in.
I'll turn it
Yeah.
on.
Turn it way out, back max. Ben?
Presented by U.S. Navy researchers later this week warns it could happen in as little as 7 years. 7 years from now.
Well, let's look at the data. He does say that, so just want to prove to you. This is the Arctic sea ice data from, I would say, 2007 until today. Can you guys just give me a break? Where is the Arctic sea ice? Does it go away completely as what Al Gore is doing? This is what they do, is politics pressuring a lot of these people who generate the computer model to say statements that they're not really supposed to say. So a lot of these scientists are a bit weak because maybe faced with some kind of fame like that, right? That they are compelled to generate implausible scenario to make sure they can get a Arctic sea ice disappearing. It's very easy to do. I know how to do it, but I would never do it, right? But some people are more compromised. I guess their nature is a bit more relaxed. So now another one is actually, sorry, it's too fast. Where is it? What is going on here? Hold on. Man, it's not going back, this thing. Okay, I'll use this. Sorry about that. It doesn't go back, man. Anyway, let me just finish here. The point is that the climate model is not doing its job. It's just very, very difficult to represent the Earth correctly with all the right physics. It doesn't go back. Yeah, to start from here is enough. Yeah. Right, that was a Glacier National Park because they say Glacier National Park will all be destroyed and disappear by 2020, and then by 2020, when it didn't disappear, they remove all the signs over Glacier National Park. This is all documented. So this is the kind of error that you don't want to make, okay? This is actually a very famous event in Paris. It's Tuesday afternoon, 4 p.m., where you have a major mistake, the brake fail, and then you cause a serious problem. But I want to say that climate models are wholly unreliable for many tasks. The reason why is very simple. They cannot simulate many regional or large-scale phenomena correctly. Robustly means statistically correct, right? And then when we see agreement, we can be sure that the model can get them for the right reason. That's very important because model always get it right for the wrong reason. That's thing we know for sure now, right? And they cannot make any meaningful projection about future climate, even just to control one variable, which is CO2. Because you have to consider sea ice, you have to consider cloud, you have to consider sun, you have to consider the UV sun, you have to consider so many other factors, ocean circulation, right? So I would say that problem with climate model is garbage in, gospel out. Because if it's garbage out, people like to say, garbage out, but I say gospel out. It's the gospel that is very dangerous. Because they use that to make policy, to set policy. And that's very dangerous. We don't want that. Now let me explain the basic of CO2. Hopefully you will be able to learn this a bit. This is the thing that they don't talk about. You want to talk about in the context of energy flow among different systems, right? So it is a greenhouse effect. There's no doubt that you add more CO2, you're able to affect the flow of the infrared radiation in the system. So if you have more of it, probably it will slow the flow, so it will actually warm the system. But there is another greenhouse effect, greenhouse gas in the system. Do you guys know what is the largest greenhouse gas in the system? Water vapor. Yeah, it's not water only, vapor, right? In vapor form. Here's what it is. This is what it is. This chart is a simplified chart. CO2 affects only one component, which is the atmospheric composition. The water vapor effect, what do you think? Atmospheric optical property, the albedo of the cloud, the land albedo, the ocean flux, the relative humidity, soil moisture, evaporation, surface vapor pressure, precipitable water vapor, latent heat flux, right? When you form clouds, this water condense, generate heats, right? That kind of stuff. And that's unfortunate. They ignore H2O for the sake of this carbon dioxide. That is that's too much of a cherry picking. This is why they are capable of showing this. That is natural CO2, the one that come out from power plant is evil CO2, right? That's just not correct. That's not a healthy thing to keep going on this. That's why I challenge Al Gore or any scientist. Those so-called scientists wanted to talk about this, let's talk about this. Here's another example of showing you why water vapor control the temperature. The relationship is very, very close, okay? It's very, very tight. The top panel showing you basically the distribution of the temperature from North Pole to South Pole and then go up vertical height about some 25 kilometers or so. The red means hot, the green means slightly warm, cooler, and then blue is cold. And then you see the distribution of water vapor. In one instant, it's almost controlled by water vapor. That shows you the system is really governed by that. And here's over time, you can see two lines. The red line is actually the water vapor content. And then the blue line is the temperature curve. This is the one that Professor John Christie measured, okay? The temperature curve at the atmospheric layer using satellite. Very accurate measurements. And it shows that this whole thing is controlled by water vapor. And then lately, my good friend Dimitri Kosoyanis from University of Athens, the technological university, shows that if you compute the number, how large is the infrared role for the CO2, it's actually at most 4 to 5% from looking at long wave IR outgoing or even long wave warming, because the radiation can go both ways, right? One go down to hit the surface, one is going to escape away. It's just no more than a few percent, okay? So it is a puzzle. Where is the CO2 doing now? It's continuing to rise. It's amazing, isn't it? It's continuing to rise, but yet we still cannot see it in the temperature record. Why? That's the question. That tells you the CO2 effect is secondary. And here is just a very nice relationship between rising carbon dioxide and actually more of this United Nations climate of conference party, COP. Okay, it continued to have meeting after meeting. The next meeting will be in Brazil. Okay, November 2025. The last one was somewhere in Azerbaijan, I think, Baku. But here's the actual greenhouse effect being measured, that you measure. There's a group of scientists already measured this. Here from 1980 to about 2015 or so. You can see that the greenhouse effect is increasing, but from 92 onward, it started to go flat. Actually, remember, carbon dioxide keep rising, but why is it doing this? If carbon dioxide is driving climate change, think about it. So technically, we know that this thing go flat because the effect is come from cancellation effect of water vapor and cloud. It has nothing to do with carbon dioxide. And that is a scientific kind of a level of proof that you need, which I think you don't need. So that's an actual scientific paper. So all you need is Albert Einstein to say a statement like this. Because when he formulated his general special relativity, I remember, it's 1904, 1901, there were 100 Berlin academicians published a pamphlet, say that Einstein is wrong. So Einstein calmly said, you know what, if I were to be wrong, I think that one would suffice. Why do you need 100 of these people doing this? I mean, that's why he said, no amount of experimentation can ever prove me right. A single experiment can prove me wrong. Okay? So now let's look at the CO2. What is it? In the biosphere, it's the gas of life. It's not satanic gas. This is actually a container with concentrated carbon dioxide because you want to put it in the greenhouse, especially during winter. Okay? The statistic is, of course, I have a very old statistic from the 2000 that the Canadian during winter, the money is about few $1 billion, to do greenhouse kind of tomato, cucumber, things like that, right? It's a very, very thing. You want CO2, you want more of it. And think about CO2. What is it? I told you, come out from our thing. Outside there is about 420 parts per million. Do you know in percentage? It's 0.04%. Okay? And here, from the human breath, is 40,000 parts per million. That's 100 times more. And then when you are very excited, like Al Gore, you hold your breath, and then you breathe out, it's 80. Okay? Don't get too excited, Al Gore. Wow, you should do that to save the earth, to produce more CO2. Here's an actual experiment done by my colleagues. Okay? Sherwood Itzel and Craig Itzel, which is his son. They have done a lot of this kind of experiment where you can enrich the carbon dioxide in the tank and then you see how well the system grows. In terms of not only the plant, the leaves, the root system. You can clearly see that the one with very high concentration of carbon dioxide, that's a lot more, healthy in that sense. So we have to be careful. If we want to put CO2, by the way, from such experiment and from natural world study, we kind of know that if we have CO2 below 200 parts per million, we're in serious trouble. That's an ice age level problem. Remember New York? Remember 20,000 years ago? I have older memory. It's 2 months thick of ice, okay? We have serious problem dealing with cooling, believe me. Warming is not much of an issue in some sense. And then there are people in Harvard School of Public Health also trying to grow poison ivy, ragweed. They got grant from our taxpayer money to do those kinds of useless experiments, to try to say it's going to cause kids more asthma, this and that. That's basically what it is. It's a blatant kind of abuse of science in that sense. Of course, we should be concerned about kids' asthma. I'm not saying that don't be concerned. But don't do that in the lab, get paid like millions of dollars to do this kind of experiment. We know it's going to produce, but you got to think about producing, let's say, leafy stuff, right? You got to think in that way. It's just a wrong framing of a question. So I challenge people who think wisely about this problem. Now the good news is from rising carbon dioxide. What does it do? It actually greened the whole planet. We have a satellite up there measuring this thing for almost 30 years now. Okay, this is the latest result coming from a group in China, Peking University, and they measure this thing. It keeps increasing. The planet keeps getting greener. That's some good news. Please, how many of you have heard of this in the media level? No one ever talked about this, which is a puzzle. No wonder you think that CO2 is so bad, right? I mean, here you talk about the distribution. There are places that they get drier, less green. That is true. It's not 100%. But large majority, over 80, 70 to 80% of the area. But the most significant one is that near the margin of the desert, the dry area, get greener. You want to know why? I think I'll have slides to show that. But there are places where you can show China and India are getting really greener, okay, overall. So people would say, save our desert, no more green, right? They don't like desert to be green in some sense. And then in China, there's a famous place called the Loess Plateau, which is all dust and all those kind of fine particles. It's actually greening up. This is actually things that you cannot geoengineering this way out. This is nature, a very powerful thing that if you have more carbon dioxide in the air, this is what you get. Of course, some people may prefer this. I don't prefer this. I kind of like this one better. It's your choice, okay? But let's not do this kind of aggressive thing. No, you want to cut carbon dioxide. In fact, I say, who asked you to do that, right? For even India, places where they look for food all the time, crop yield is completely increasing. I don't say it's directly from more carbon dioxide, but it's partly related. It's technology, that kind of stuff. But even the latest one, 2025 update, they actually have a government report, very, very major record high of things. So good news overall in India. But now let's go back to the reason. Why when you have more carbon dioxide, it's greener planet, and then the desert zone is getting, because when you have more carbon dioxide, the most problem of all the plants is basically they loses the water, right? The stomata open too much, right? Then they you know, when you have very little CO2, they have to open more to get more thing in, so they lose more water. But when you have a lot of CO2, the stomata closes. Stomata are those tiny little pores behind the leaves. You can look under a microscope and see those things, right? So it actually closed down, so it uses the water more efficiently. So places in dry region, you can see this result. This is scientific result, by the way. This is showing you graph that in terms of water use efficiency, if you quantify that number, over time it has been doing better and better. So in some sense, this is a great blessing. In fact, we are very afraid that China, like my great mentor in science is a guy named Freeman Dyson from Princeton. He actually said that we better be worried a little bit about China demanding us to pay them money, because they're putting out a lot. China is putting out a lot of CO2 in some sense. I'm not laughing because this is serious, because this is actually money, you know. So indeed, there are people who deny that the planet is getting greener. So they say it's blue, so what can I do, right? If you're blind to the evidence, I don't know what to do. In fact, there's a very nice statement from Supreme Court, late Supreme Court Justice Scalia, who actually in April 2nd, 2007 decision, US EPA versus Massachusetts. That was under Bush administration. Unfortunately, that was also a wholly badly argued case, in my humble opinion. So we lost the decision 5-4. So US EPA must label CO2 in the air as air pollutant. Can you believe that? This is human law, super overriding the biological principle. And that's very dangerous. So I say this shall not stand. This is why Scalia is so frustrated that this is actually a tiny little footnote in his decision, his dissenting opinion. He actually, that it follows that everything airborne from frisbee to flatulent qualify as an air pollutant. This reading of the Statute of Clean Air Act, by the way, right, defy common sense. I think this one is something that we can fight all the way to the end, because I really think that this shall not stand, because it makes no sense to call CO2 an air pollutant, okay? Where the amount of scientific evidence, and please don't say that science allows you to do that. You want to do it any other under excuses, I mean, by all means do it, you know. But we are not going to let this stand. I have a few more slides to show you. Please be patient with me, right, with all this lot of hiccup. I want to talk about my last part of the talk, which is about my result. How does climate change? So this is very exciting work done with two of my Irish colleagues, Ronan Connolly and Michael Connolly. We have done work published for almost 10 years now. It's very exciting. People who want to read, like I say, you're not going to read it now, please, or else you'll become crazy. It's a lot of papers, but scientific paper is where you document the details, where we can allow IPCC scientists to challenge or agree to disagree and that sort of thing. That's a very healthy thing. But unfortunately, this day they're hiding away. Even though they know our result, they will never cite it, they will never let people know, they will tell people, shh, keep quiet, don't let people know, Willie soon come, we'll run away, you know, give him 5 audience, that's okay. So it's bad. But now, first thing, thermometer data, what is it? Look at that, this is one of the standard thermometer data in California. Look at where the thermometer is standing. It's surrounded by air conditioning van, the parking lot, the asphalt and all that. This is telling you that a lot of our thermometer data is in serious trouble. There's a thing called the urban heat island effect, right? In fact, if you want to watch, my son produced a very nice video on explaining urban heat island effect, so I can provide a link for anyone who is interested. And these things are very real. It's a serious thing, because as we develop, we do affect our system. There's no doubt about this. Except what are we going to do? Okay? We're seeing different kind of climate, okay? This is human climate in that sense. So here's the best example, which is Washington, D.C. On your left is a heat map, which show you the temperature, how hot. Hot is orange and then cold is blue region. You can see, if you look at the Landsat data, it's actually either concrete versus the park, green park, or the waterway, the Potomac River, right? You can see it's very strong. And the effect is not tiny amount of CO2 that you're looking at, it's 17 degrees. It's a very serious phenomenon. And then these folks from IPCC, from US EPA before, and then the what you call global change research, you know, US National Global Change Research, say that those results are not correct. That, you know, they are correct, they are okay, the temperature data. To prove to you the urbanization effect, I want to show you this. On the left, is the thermometer data from the 20% most urban area. On the right is the 20% most rural data. And then if you compare them, you will see the warming is 80% more in the urban area. That is actually scientific. This is called proof. We actually show this. That we show that this urban heat island effect is not happen only in New York City, Manhattan, it's over the whole Northern Hemisphere or in whole United States. This is a very serious question to ask. And I want to tell you that the IPCC, United Nations Intergovernmental Panel for Climate Change, they write report year after year, but the chairman of the group knew about our work, in fact cited my work positively. He's from China. And then after that he know that people start hearing us, then they no longer want to talk to us, of course. But it's okay. The result will stand. It will stay there forever because you cannot hide away from truth. Here's another good example. It's actually Tokyo and one island called Hachijojima Island, 180 miles away. You look at the temperature record. By the way, I just give you an example. It's everywhere the same. Science is like that. I'm not hiding anything, Paul. Look at the temperature record. The blue one is obviously from the island, right? And then that one, urban city, Tokyo is highly urbanized. It's completely different day and night in terms of temperature warming trend, okay? So when you use record like that, you have to be very, very careful what you do. So science is not good enough just to complain about people's problems. So how do you solve it? We actually come up with a very simple thing. In fact, it's so simple that I'm really embarrassed that we have to write scientific paper on this. And you know why, right? Do you know why? No one has done it before. That's the appalling part of the story. And those guys have been funded a lot by our money. I myself asked for private donation, put it this way. So we went through our temperature record and then we analyzed rural China, Arctic Circle, rural US, and then rural Ireland. They are biased, obviously. And that's the temperature record. It doesn't look anywhere close to what they are talking about. You know that warm thing at the end, that correlation thing? And then it looks more like the bottom line, that one, the one here. It has warming, it has cooling, it has a warming again, okay? So it's very oscillatory. If you compare with sea surface temperature, which have no urban heat island effect, what does it do? It's rather reasonable, isn't it? If you look at the tree ring record, tree ring also in mountain region, they don't affect by urban heat island effect. They also look more simple. And then if you look at the ocean, it looks also similar. Okay, warming and cooling. So what is it that is doing this? It's Bob, right? B-O-B, bright orange ball. Here's the answer. The red curve now is the estimate of the sun energy output, the best estimate. And then the blue curve is actually the northern hemisphere temperature, but only using the rural station. Do you understand? That's important, and we published this paper. I wish for them to discredit me. Here's the USA temperature, the one that rural temperature. So I think we're pretty convinced that there's something good there. So what's the real reason? What's the real reason for that connection? It's actually, I show you, is water vapor. That's the reason why I mentioned water vapor to explain to you. Okay? Sunlight evaporates the ocean, more water vapor. That's simple as that. This is as simplest of the hypothesis, and no one even look at it and talk about it. When you talk about it, they look at you like you're not right. So I don't really care in that sense. You know what I mean? I am confident of my work. Okay. Finally, let me just give you a big perspective. The sun, okay, is the most enormous, what you call power fireball, powering the earth. The earth is 2 billion times weaker in terms of the total power. Okay? Even that energy comes from converted energy, because we have measured how much energy can come out from the earth itself, which is from where? Radioactive decay, radon, uranium, all this other stuff. We actually measure that dedicated measurement in Italy, down in the tunnel. We measure only like 2 times 10 to the 13, where the sun is 2 times 26. Okay? So billions and billions of order, right? So that's a serious problem. So we know it has to be the sun in some sense. That's why I think it makes sense when you have data to support that. You need to understand the rationale. It's the energy output and input. Okay? If you look in terms of CO2 per molecule, the CO2 number we can quantify, 10 to the minus 22 watt. It's a very tiny amount, but you can say, okay, I have this room full of 10 to the 26 molecules of CO2, for example, right? Because that's the density of the air. Even you multiply by 10 to the 26, you're not going to get anything out of it, okay? It's just not amount of energy. So one final video. I hope this one works. This is good. No sound, guys. Let's play again. This is a very fun video to watch if you can make it very loud. Okay, unplug and plug again.
Was working earlier. Do you have much more videos?
That's it. That's the end of it.
That's the last one.
So my last 2 slides. It's okay, guys. If you like, really, I will send you the file, obviously. Please write, and then we'll send you. It's a fun video to watch because he's talking about sitting in a camp, and then you burn your marshmallow, and then you're blaming, you say, oh, turn off the fire cam, right? Because turn off your cigarette because you're heating things up in a campfire. Anyway, that's it. The final line is basically CO2 is not a control knob for the weather and climate, right? It's absolutely not a thermostat. So the takeaway message is that rising CO2 has not caused the globe to warm or cool rapidly or even gradually. Instead, climate in USA and elsewhere is obviously disconnected with CO2 level. The sun is a clear factor for climate change. So you cut CO2 to zero, you will not change temperature or precipitation in the US. In fact, you will kill or hurt poor people. Actually, I use the word kill, okay? And greatly harm animals and the environment. So this is a very serious thing for us to pay attention. Thank you. Sorry for going over time.
We have Q&A, very short period of time for that. Please line up here, if you will, and I will hold the microphone and you do the talking, okay? And those of you who want to ask a question, call on your, yeah, it's okay. We have to pay you a scale now for that, Mike. Okay, you first. I'll talk. You talk.
Oh, don't you have a question first?
Yes, my question is, so in Germany, and I think around the world too, they have problems with like the methane gas from cows. Could you speak a little bit about that? Because like, from my understanding, that is like almost, that contributes nothing to global warming. And in Germany, they're trying, and in European countries, they're trying to basically like limit the farmers on how much meat they can produce for the population. And
on the issue of methane as a greenhouse gas, it's always been highly misrepresented, I would say. Methane, as you know, that in an air like this, it will be quickly oxidized by any amount of oxygen. So it's very highly ineffective. All these are just purely to put you in a myopic picture, to frame it only that way. But if you don't think about atmospheric lifetime of the carbon methane itself, it lives in the atmosphere no more than 5 to 10 years. That's it. Okay? So the point is that it chemically becomes something else. It turns into water vapor, by the way. That's the source for the hydrogen to make water vapor in the atmosphere. So those things are highly misleading. And then German, of course, God bless them, they love to shoot themselves in the foot, so let that be.
Okay, here we go. Somebody asked me to ask you this question. It said, I wonder if you or ABC members may ask a question concerning the current statistics and reality on the U.S. emissions of CO2 from all our activities. You may have covered that, but that's a question.
I think I will do that with the slide because there's some very powerful information here, right? So I pose the question, how about CO2 emission from all human activity sources? What's the latest update, right? I bet that none of us have seen this from the US. I now plotted the US contribution of CO2 from fossil fuel from 1970 until 2008 or so. So it rise up, right? It does make sense. Can you guys actually want to make a guess what happened since then? It actually went down. How many of you know that the US carbon dioxide emission has been going down? We can explain this, by the way. It's because we use more methane. It's actually the fracking revolution that we find this much more friendly sort of fossil fuel to use, right? And it's actually decreased quite a bit by 18% or so. Think about it. We already down this by 18%. What more do you want to do? Do zero? Do you want to go down to zero? Then please turn off all the air conditioning, turn off your refrigerator, don't drive it.
Stop breathing.
Yeah.
Okay.
It's a very serious thing. Yeah, and then you can see the power sources from electric sources is actually down by 38%. This is why, good news is that the US EPA, the administration, Lee Zeldin, which is your New York home-based kind of guy, I mean, he is actually proposing that we really should not put much more pressure on the US system in terms of generating electricity. We should free to generate more electricity, right? So we should not worry about that because the amount of CO2 is just keep decreasing. It's actually becoming not significant even.
Okay, time for a couple more questions. Please, Karen.
Do you think that the powers that be, the establishment, really believe that humans cause carbon dioxide production, or do they have another agenda? And that's why they're putting forward the narrative that human beings are to blame for our problems.
I'm leaning towards yes. They knew, because all this data are publicly available. Please, we don't generate this ourselves. I mean, it's all available. They knew about this decreasing thing from the US, but please don't tell anyone. Hopefully nobody checked. They keep doing things like this, which is very childish. Don't you think we cannot rationally have a policy that makes any sense at all? Why can't we talk about it? Okay, you want more wind and solar, let's talk about it. Why? Explain to me. How do we lower the cost? How do we not destroy the electric grid? I'm not against solar, but it does destroy the electric grid. You all know about the thing happened in Spain, right? It's because of the wind and solar that's actually taxing the system so much, they have the whole blackout for whole two days or so. Anyway.
I noticed on your slides it said the temperatures in relationship to the land. Can you say anything about how the models and your model relates to the temperature of the oceans and its change?
Well, we haven't done very serious modeling on how that, but it depends on the factors. It does, you see, you can show the relationship. They are quite close to each other, like how it affects the sea surface temperature, for example. Yeah. That one, we have done that. We're confident that it's a physical relationship rather than statistic. Remember, when I criticize this thing, joking aside, you cannot just do that and use that for yourself, and then go ahead and criticize people. But we work on those kind of physics. It worked out. The number is all good.
More on a policy basis here. So over the last number of years, government-sponsored science has become increasingly divorced from the application of scientific method, and many people, especially the press and politicians, cannot differentiate between conjecture and results from scientific method. So do you anticipate that in the future the U.S. government policy toward funding science will require the strict application of scientific method to be proper science and not conjecture, and will require, all studies should require a formal critique on either side of the argument?
I don't know how to institute that. I'm merely a scientist, but I would hope so. I would hope there will be more adults in the room. That's the problem. We've been run by a whole bunch of delinquent teenagers. Very delinquent in some sense. Borrowing a phrase from my friend from Canada that wrote a book called Delinquent Teenager. It's very bad because it's very sad. Yes, you go to conferences, you go to all the major things. Even students, supposedly aspiring young rising mind, supposed to go and study, instead of asking the question, what is weather and what is climate, the whole topic is fascinating. This is why I'm still in it, okay, despite my complaining, this and that. But I love the science. Instead of asking the question, they say they want to work on this problem because they want to save the planet Earth. They haven't stepped back and asked themselves, who give you the authority or the confidence that you are here to save the Earth? I mean, that's a question that is a bit deep in that sense that we need to address some of that. Plus the educational background. You think about what they teach in school, right? it's also pure indoctrination, right? The stuff that they give. No one should be able to answer challenging this question. They just basically call us a denier by names. They call Professor Richard Lindzen, who's Jewish by descent, right? A denier, right? Holocaust denier in that sense. No one is denying anything. It's terrible. Thank you, thank you.
How will you talk?
Oh, okay. You're a very entertaining speaker. I heard you more as an advocate than as a scientist. I didn't hear that much about your own research. You showed some meaningless correlations, and then when you showed other correlations that you believed in, I didn't understand the mechanism. I spent my career at the National Academy of Sciences running the review process. And so to me, the hallmarks of good science are, peer review, acknowledgement of funding sources, acknowledgement of possible conflicts. I wonder if you agree with that.
100%. I want to make an emphasis that all these things that I say is largely published, peer review, yes? I publish in all the major journals as any of these folks is publishing. But I can give you the real answer to that. For me, usually all of them get a peer review system. They actually go to peer review. I got an actually honest peer review that I'm very happy with. Peer review, you understand peer? It's like people on the committee, they're reviewing each other. I was on many NASA committee, NSF committee. I can see it from behind the scene. This is what they're doing. That's why the science is poor, very poor in my view. And I just wish that they would correct that. I don't mind. I want to emphasize that all the things that I say is not just emotional. I publish those scientific papers. That actually make me, just like Professor Christie, we are the one that originally work on the science. We don't mind criticism. If we are mistaken, we'll correct it right now. We're wrong. There's nothing wrong, nothing bad being wrong, isn't it? When you are wrong in science, it's actually a pleasure because that means you're going to learn far more than you already knew. You just never say you know everything. Yeah, that's why this thing, I honestly tell you, I wouldn't be able to do this talk, let's say 15 years. Because over the 10, 15 years that I was working with the two Connellys, which is very smart. By the way, they don't have a credential at National Academy of Science. They are just chemists, both PhD chemists. And they are very, very, very smart. We look at every data possible. So the basis of science is basically in this complex science called climate, because here's a puzzle. We know that climate is something of an aggregate of the weather, but we don't know what is the actual scientific definition or mathematical definition. World Meteorological Organization say that climate is 30 years average of the weather. That sounds reasonable, but it's a very unfortunate thing, a fact, that is it's just as arbitrary as I decided to say that Al Gore is very smart or something. It's just wrong. You cannot say that 30 years, what about 50 years, what about 100 years? Because we don't know the spectrum. This is where the problem of science comes in, where no one is discussing the science. When you try to talk to them about things like that, they don't want to talk about it. And that's where the problem begins. It started long ago. By the way, I was a postdoc. I was also a very junior person. I went to every conference meeting. I was the only guy who always raising questions, asked all the questions, but no one wants to talk about things like this. I make them uncomfortable, but I keep going to conference because I'm a scientist. What can I do? I don't mind having beers or enjoy discussion with them. We do discuss, actually. But the problem is that many people are, caught up with this particular wave, this fashion, that because there's so much money is involved. And somehow people don't like, of course, the use of so-called fossil fuel, right? They think that is dirty energy. But it's the most compact form of energy. And then yet they don't want to support nuclear energy. That's a contradiction all by itself.
Okay, we have two more questions. Yes, sir.
More than 50 years ago, as an undergraduate, I had a class in earth science in which this topic arose. At the time, there was a great split of authority. There were some people who believed that adding particles to our atmosphere would cause global cooling, which could be a serious problem. There were others who thought it might be out in the wash because the effects of global warming would be offset by the effects of global cooling. what's your scientific methodology that might that could disprove your theory that additional CO2 and additional methane is actually good for the planet?
Okay, disproving myself. You're asking for me to disprove myself. I actually, every day I'm trying to disprove myself. That's what I do. I try to find way. For the particulate stuff, I can tell you the problem is basically that it may produce very temporary effects, so it's not going to last decades to centuries. It produces very instantaneous but short-term and local. That's the problem, because there's not going to be global pollution. Remember, the word global pollution, it kind of doesn't work out. In terms of tailpipes, when you don't have catalytic converter, back then the sulfur was just let out and then formed with particulates. Those effects, I think, in the science and literature is very confusing today, because they would invoke it when they want to use to explain certain things, and then they would just completely ignore it. That's why it's not science. It's just very strange. Of course, they get their work published, which add even more confusion, because you already published in peer-reviewed journal. But then peer-reviewed journal is not the answer. It's always, one can always ask the challenge, like you say, you reinvestigate. For the sun one, I think I have worked very, very hard to disprove myself, but so far, I'm not saying science is everything. All I know is that the evidence is very strong. That's all I can say. See, I never say the conclusion, I know everything, that's it. But the point is that as far as I look at every evidence that I have is fully consistent. That's about the best I can do to try to do myself. I will continue to keep looking for counter evidence, no doubt about it. Thank you.
And the last
but
question.
good question. That's a very clever thing, because the most easiest person to fool is actually your own ideas or your own notion. That is very true. And it happens to everyone, regardless of how high or how low your stature is. It's the same thing in science.
I'll try and keep this short. I'm a believer that the sun has a lot to do with climate, because I know in the summertime it's warm, in the wintertime it's cold. But years ago, I think there was something called the Maunder minimum back in the 1700s, where there were continuously cooler weather, cooler climate, that sort of thing. Have you guys done any correlation between things called the Maunder minimum, solar activity, and have you done anything to predict what solar activity would do here in the future? Are we going to have hot summers, or are we going to have cool summers? Is there going to be more or less solar activity? Do you know?
Thank you. Very good question. But I think in somewhat coincidence, really coincidental, that you asked the question about this period called the Maunder minimum, where the sunspot disappeared for almost 70 years on the northern hemisphere. There are some on the south. By the way, I was the only guy, the first guy to ever produce a semi-popular book in 2004. It's on the Maunder minimum, because I was so curious. It named after the husband and wife team at the Royal Greenwich Observatory, who observed the sun daily for 60 years. These are dedication, okay? And they are the one who discovered somehow that in the 17th century, from 1645 to 1715, you guys want to know during that time who is reigning in Paris? The Sun King, Louis XIV. Exactly coincided with the time period. So people actually have a joke saying that it was the Sun King, and therefore all the sunspots disappeared. But anyway, it's a fascinating period. Yeah, and during that period, yes, we have cold climate. Thames River flows, many things. Hans Brinker, you can see from all these old paintings and things like that. So this phenomenon is real. So the connection between sunspot activity, Maunder minimum, low and very weak sunspot activity, which correspond to very weak sun, which means the radiation coming out, the energy is a little bit less. But even that a little bit less, because it controls 99.9% of our energy input, what does that mean? That means it will change the climate too, right? It will cool the planet. And that's why we believe that there is a very clear physical relationship rather than statistical. So it's true. There's a period called Little Ice Age. Little Ice Age covers much longer period, but the coldest period in the Earth history is actually during the Maunder minimum period, the 17th century. Okay? So it's no coincidence. Yes, we have studied all those things, yes. Many scientists have studied the topic.
Ladies and gentlemen, please, Dr. Willie Soon and son Ben.